Today I will be discussing a JavaScript optimization technique which you can use in React as well, which is about throttling and debouncing. This is a very important topic, so do check out the video till the end. In any application, when the event is occurred, you never know how many times an event is actually fired. For example, when you click the mouse, it has a lower trigger rates, but compared to that, if you use the mouse over or maybe scrolling, it has a very higher trigger rate and can slow down your app. It may even crash, but it can be controlled. Let me show you a sample application to get an idea about debouncing and throttling. In this application, there is a division on which I have configured a mouse move event. So every time a mouse move event is fired, I am incrementing a counter to know how many times the event is fired. Also, I have implemented throttling and debouncing with the same event to check the number of executions. Now let's move the mouse and check how the counter gets incremented. So the moment I started moving the mouse, the normal count, throttle count and debounce count values are getting incremented. Moving the mouse again, you can see that the number differ a lot. Why is it so? Normal count shows how many times the actual mouse move event is fired. Right now it is 114. The throttling approach, the count is less than normal count, that is 14, and the debounce count is just 8. It means by implementing the debouncing approach, the mouse move event was executed only 8 times. This is just an example to understand that you can control the events fired like a mouse move event or a scroll event or a key press event. Imagine that on an event you are making a call to an API or an HTTP call or a huge process to execute within a function. In such cases, throttling or debouncing will improve the overall performance while the events are executed. To know about debouncing and throttling techniques in detail, you can check out my JavaScript course where I have an entire section detailed to this concept.